called hysteresis that we took a look, at the early part of this class. It is invoking factorial when we're inside the definition of factorial, but don't let that bother you, okay? Because what we do is we just follow the mechanism blindly. So this is completely mechanical. We do exactly the same thing. We allocate one column, we label it return line number. And then we have to remember, when this invocation of factorial is done, where am I supposed to go to continue execution? You look at the invocation line, which is line 8, and it is asked, what line is logically following line 8 in this case? This one is easy. It's just line 9, exactly. And then we also have to remember that we have to allocate one column for each local variable. In this case, we have local variable x, and once again, because it is a local variable, it starts with an unknown value. Are we doing okay so far? Okay. And when we go back, or after we set up the return line number and the local variable, when we start executing inside the invoked subroutine, we always start from the very beginning. We never start from the middle. In this case, we start with line 3 again. Line 3 is asking x is less than or equal to 1, and once again, the answer to that question is false. Then we go to line 7 again. We skip the then portion. Oops, sorry. Yep, I messed up. Line 3 is making a copy of n into x. N is now 2, so 2 is now stored in x, but we are no longer talking about column F, we are now talking about column H. Are we okay so far? In other words, the right... Sorry?
What happened? I got lost.
Okay, we are... Well, that's the nice part about the trace. When you get lost, it's easy to reestablish where we are in the execution of a program. So let's take a quick look here. Let's go back to row
11. That's where I got lost.
Okay, row 11 of the trace is the execution of line 3. Are we okay with why we are on line 3 of the pseudocode?
No, that's why I'm lost. I went to 4.
Okay, we are there because of line 8. Line 8 invokes factorial, right? The invocation of a subroutine has 2 steps. The first step is to allocate columns that we need for the subroutine. Remember where we are supposed to go back to? That's the first step. The second step is to continue execution in the subroutine that you are invoking. And that's why we are going to line 3, because we're invoking factorial, and line 3 of factorial is the first line that does something that is needed.
Oh, okay.
Okay? In other words, it is the same mechanism of invoking a subroutine as everything that we have talked about so far. We have not changed the mechanism at all. Then we move on to line 4. Okay, line 4 is asking x is less than or equal to 1 is false, because 2 is less than or equal to 1 is false. We go to line 7 again. We decrement n becomes 1 this time. Then we go to line 8, and then we do exactly the same thing. In fact, at this point, you can call this program somewhat boring because it is doing the same thing again and again and again. This time we allocate column I. We have to allocate return line number first, and then we remember the line that is logically following line 8 is line 9. And then we have to allocate a column for local variable x, and once again, because it is a local variable, it starts with an unknown value. So there's nothing new at this point. Okay, everything at this point is kind of repeated and repeated and repeated. After we set up those 2 columns, we continue execution in the subroutine, and in this case, we are continuing on line 3. Are we okay so far with why we are back to line 3 again?
Yes.
Okay.
This time.
Very good. That's okay. And line 3, once again, is copying the value of n into the local variable x. N now has a value of 1. We copy that value to column J this time because column J is my current context. Okay, the rightmost part of the spreadsheet tells you, which variable you should be using at this point. and x gets the value of 1. Then we move on to line 4. Line 4 is going to evaluate the condition again. X is less than or equal to 1. This time is true because x, or column J, now has a value of 1. 1 is less than or equal to 1 is true. So this is the time that we execute line 5 instead of line 7. And now this is important because at this point we stop the recursion. In other words, this particular invocation of factorial does not invoke itself again. In other words, at this point, we are starting to unroll everything. We are basically rolling everything back to the beginning. So you will see what I mean by that. Line 5 by itself doesn't do anything that is too spectacular. All it does is to initialize the global variable r to 1. Okay? Doesn't seem to be very, very important, but it is. When we are done with line 5, we continue execution on line 11 because line 5 is the only line in the then portion of the conditional statement. When we are done with it, we get out of the conditional statement, and there's nothing else to do, so that's why we end up on line 11, which is the end of the subroutine. What do we do at the end of a subroutine? Two things. First thing is to look up what is the return line number telling me to go back to. It tells me we're supposed to go back to line 9, and that's why the next line, or the next row of this trace, will be line 9. Then the second thing we have to do is to deallocate everything that we have allocated for this invocation of the subroutine. Now remember what I said, we deallocate everything that we allocated for this invocation of the subroutine. Okay? In other words, it is on a per invocation basis again, not on a per subroutine basis. What do we do on line 9? Line 9 in the pseudocode says we want to compute r times x and then have the product stored back into r. Okay? R is easy. R is a global variable column D. It has a value of 1. What about x? Which x are we talking about here? Can we still be... Well, can we be referring to column J? No, because column J is deallocated. Now, with column J deallocated, which part of the columns, or which columns becomes my quote-unquote rightmost columns? Column H. Okay, column H and column G, they become collectively my rightmost two columns. Okay, so when we refer to X, we are now referring to column H. Column H has a value of 2. 2 times 1 is 2, so R is now updated to have a value of 2. After line 9, we get out of the conditional statement. We go to line 11 again. Line 11 is going to do exactly the same thing as last time, but this time we utilize column G to tell us where to go back to. Column G tells us we have to go back to line 9 again. And after that, we know that these columns are no longer in use. We mark it as deallocated. And now we continue execution on line 9. What do we do on line 9? Same thing. We want to compute the product of R and X. R, once again, is easy because it's a global variable. It has a value of 2. But the X that we are talking about is actually column F, because all the other columns, column G, H, I, J, they're all deallocated at this point. So the column E and column F are quote-unquote my rightmost columns at this point. Column F has a value of 3. 3 times 2 is 6. We store 6 back into R. Column D is now updated to a value of 6. And then we get out of the conditional statement. We get to line 11, which is the end of the subroutine. And we do exactly the same thing. We look up the most recently defined return line number. In this case, it is column E. Tells me that we have to go to post. And then we deallocate the columns that were allocated for this invocation of the subroutine. And then we continue execution at post, which means we are done. End of trace. And in fact, 6 is the factorial of 3. So we did compute the factorial correctly. Are there any questions about this code? No questions? Are there any questions about which variable x are we referring to? Because at one point, there are 3 columns, they're all labeled x. But even though they're all labeled x, the only columns that you can see are the rightmost columns. In other words, on line 3 of row 16 of this trace, column H and column F are basically invisible to that subroutine at that point. Any questions? No questions? Okay. If there are no questions, I will save this file first. And then we'll talk about the limitations of local variables, because there are limitations. There are certain things they cannot do. Well, let's just take a closer look at this program here. What is the purpose of n? If you look at this code here, what is the purpose of n? Let's take a look at all the lines that has something to do with n. The first thing is line 13. Line 13 of the pseudocode says n is initialized to 3. And when you look at the rest of the program, x is kind of a copy of n. And on line 7, we decrement n by 1, and then we invoke factorial. In other words, n is serving a purpose of passing information into a subroutine. Okay? We're telling the subroutine, hey, I want to find the factorial of 3, and the global variable n is used to serve the purpose of, okay, you want to find the factorial of which number again? Well, look at the global variable n. That's the number. I want to find the factorial of that number. Okay. Are there any questions about this? That n is serving the purpose of specifying, which number's factorial do I want to calculate? Is that okay? Okay. There is a separate mechanism that can do something like this. So let me save the program again, but this time I'll save it as factorial with parameter. Now you have to remember why we are trying to introduce local variables. Why did we introduce local variables?
So that variables don't. So each time you run through the subroutine, they don't interact with each other. You keep the values separate.
Exactly. It stops the interference, between subroutines and even between invocations of the same subroutine, which is even better. Okay. Oh, I just remembered what I was about to say about, we were talking about Commodore 64s, before the class started. And, some people might have programmed in Apple Soft Basic or Commodore Basic or some of those older variants of Basic. Has anyone programmed in Basic before? The really old Basic, not Visual Basic.
Yeah, but I forgot it.
If that's anything about it, I mean, you had to use Commodore, but that was about it.
Okay. Well, it had a mechanism called GoSub, and GoSub stands for, go to a subroutine. Okay? And it also has a mechanism of returning. Unfortunately, the return line number, or the same concept of a return line number, is static. There's only one return line number per subroutine. Okay? Now, can you guys see the differences between what we're doing here? There's a return line number per invocation.